All right, hello, hope everybody's doing okay. I have a very weird makeshift recorder right now, so we're gonna see how this goes. I'm probably gonna have to go back onto campus to get my dock cam. I would show you what I created, but I'm using my phone to record and it is taped to a box of books right now. So let's start chapter 8. This is going to be about graphing quadratic functions. Today, this first part of 8.1, we're not going to get into graphing yet. We're going to just talk about the parts of a parabola, which is the graph of a quadratic function. So as always, you have your I can statements, vocab, and then the start of the section. So students will be able to use zero product property. Oh, this one. Graph a quadratic in f of x equals ax squared. Okay, this one means find roots / 0 / x-intercepts. Those are all the same thing. Okay, so here's vocab. So you'll want to pause on your screen as we get to go through this, because I'll probably talk about it faster than you'll need time to copy. So a quadratic function, this is review. We talked about these with our last section with factoring. It contains the largest degree or exponent of 2 on a variable. So they look like ax squared is what we're going to learn to graph in this section. Ax squared plus c is the next section. Then ax squared plus bx plus c, which is what you were factoring, those trinomials you were factoring, where c represents a constant. And a constant is just a number. Then we have this new word, parabola. You might want to practice saying that, parabola, because it looks like parabola, parabola. So it's the U or rainbow-shaped graph of a quadratic function. So anytime we see a graph, a function that looks like this or like this, that is a parabola. Okay, vertex is the highest or lowest point on the parabola. So if it's U-shaped, it's the lowest point where the arrow is pointing. If it's rainbow-shaped, it's the highest point where that arrow is pointing. That's called the vertex of the parabola. Symmetry, this is just a general word, symmetry. One that many of you are probably already familiar with. It's being identical on either side of some invisible line. So squares have symmetry, right? If you fold them in the middle, they're going to be identical on each side. Circles, if you fold them in almost any way through any center, it'll be symmetrical on both sides. Triangles have a line of symmetry too. But how this pertains to what we're talking about parabolas is this axis of symmetry. We'll abbreviate it in notes sometimes as AOS. And that is the line of symmetry for the parabola. So it's an invisible line, right, that you'll have to identify. So if this was the x and y axis, and here's a parabola, this vertical line that goes through the vertex is your axis of symmetry. And when you tell me what the axis of symmetry is, you'll always say it the way you would tell me the equation of a vertical line. X equals, and whatever that x value is that it crosses the x-axis at. So x equals some number. So if I say label this, you'll go AOS, the axis of symmetry is x equals, let's pretend that this is 1, 2, 3. X equals 3 in this fake example. Okay. Remember to pause at any points. So here is a big note chunk. This is talking about the characteristics of these parabolas. So this is the parent function. Remember, we talked about parent functions before. I wish I had a highlighter on me. I do not. I'll get one for the next video. The parent function is f of x equals x squared. Parent function, let me include this whole thing. F of x equals x squared. And then everything else is just a transformation of that parent function. We talked about this before with exponential functions and linear functions. So, like as we see on here, here's our parabola, x-axis, y-axis. Because this is the parent function, its axis of symmetry is just the y-axis, so that would be the line x equals 0 for the axis of symmetry. The vertex of the parent function is at the point 0, 0. The vertex is a point, so you'll tell me what the vertex is in point form, parenthesis x, comma, y, end parenthesis. And then you have to describe the end behaviors. This side is decreasing, this side is increasing. We think of this the same way we thought of exponents. If you were walking left to right, so the way we read, left to right. If you start here and you're walking, here you're walking down to the vertex. So you're decreasing on this side of the vertex. Here you're walking up, so you're increasing on this side of the vertex. Okay, then there is the domain and range, which we so barely talked about in semester 1. Domain is all possible x values of a function, and the range is all possible y values of a function. So, domain for parabolas with arrows on the end is always going to be, as it says right here, all real numbers. It's always going to be all real numbers, the domain. And that is because these curves are angled to a side, which means eventually, because the arrows mean we're going to go on forever, eventually every single x value on a graph will be passed by this line. So what we see here is only -4 to 2, these guys, but the continuous pointing, the infinite arrows tell us that eventually it will hit every single x value. Y, on the other hand, our range is not all real numbers because there will never be, in this case, this U shape, there will never be any y values below this vertex point. So that's where y is -2. So the range, it says here, the range is all real numbers greater than or equal to -2. You can also write this as an inequality. Y is greater than or equal to -2. You can write it as a sentence or as an inequality. I'm okay with both. Okay. And then this is talking about when it's increasing and when it's decreasing. So remember, it is decreasing, going down to the vertex, increasing, going up from the vertex. The vertex has an x value of -1. So its axis of symmetry is x equals -1, which means it's decreasing when x is less than -1, so on this side of -1. And it's increasing when x is greater than -1, so on this side of -1. You could also say that as decreasing to the left of the vertex, increasing to the right of the vertex. So it's decreasing left of vertex, increasing right of vertex. I'm okay with describing it either way. All right. So Explain and describe important characteristics you should identify on a graph, specifically a parabola. So the things I want you to be able to identify is its shape. Is it U-shaped or rainbow-shaped? So does it open up or does it open down? Tell me the vertex as a point. Tell me the axis of symmetry. Oops, I should say x equals a number, not y equals a number. X equals, and whatever the x value is that it crosses through. The domain and range, and the behaviors, where it's increasing and where it's decreasing. So let's draw one and identify and label all the characteristics. So we're just making this up so it can look like whatever we want it to look like. No parameters here. So let's have it be rainbow shaped. It's not perfect because it was created just freehand. But here, based off of what we've talked about so far, we're going to have to make up okay. Which actually means if I want to draw this better, because it needs to be symmetrical, it should probably be more like that. Okay, so my vertex is at the point 1, 2, 3, 4, comma 1, 2, 3, 4, 5. 4, comma 5, right? Here's 1, 2, 3, 4, 1, 2, 3, 4, 5, okay? Which means my axis of symmetry is at x equals 4. The shape is rainbow. It opens down. So we've done shape, vertex, axis of symmetry, domain, and range. So domain, capital D, domain is always all real numbers. And range with a capital R will be when y is less than 5, right? Because there's no y values above this. The graph doesn't exist above this point. So when y is 5 is the biggest. So I can either write it as when y is less than or equal to 5, or in words, when the y values are less than or equal to 5. You can write it either way. And then the behaviors. So the behaviors of this graph are that it is increasing, right? If we walk left to right and we're walking up to the left of the vertex, and we're walking down to the right of the vertex. So we are increasing to the right of the vertex, or you could write it as increasing you could do increasing, abbreviate it, it's an up arrow, increasing when x is, oh sorry, it's supposed to say to the left. Increasing to the left, the side of the vertex, so increasing when x is less than 4. And then decreasing to the right of the vertex, so decreasing when x, it's a really bad W, when x is greater than 4. Okay, I'll let you copy that. Alright, so we're going to move on. Next page, almost done for today. Identify the characteristics of the quadratic function in its graph. So what is the vertex? Label the vertex. Right here, when it says label the vertex, I want you to put the point on the graph and write vertex. And then down here, you'll put vertex, and then tell me what point that is. So that's -1, 1. Okay? Axis of symmetry. Same thing, draw and label. I want you to, on the physical graph, put it on there and label it as the axis of symmetry. And then right down here, axis of symmetry is x equals -1. Notice the axis of symmetry line is also the x value of the vertex. So if you don't have the same x value here and the same number after your equal sign here, something went wrong. Okay, domain is always all real numbers. And then looking at our graph, our y does not exist down here, so our y's don't start existing until y is equal to or greater than 1. So the range is y is greater than or equal to 1. Notice my range is the same. My parameter for my range, the number I put there, is the same as the y value in my vertex. So you always know range is going to be y, sum inequality symbol, and then the same y value you put in your vertex. You're just going to need to know when is it greater than and when is it less than. So it's greater than when we have a U-shaped graph, and it's less than when we have a rainbow-shaped graph. Okay, and then behaviors show on the graph. So here, we're decreasing. If we're walking left to right, we're walking down. And here, we're increasing. Again, I would want you to label that, show me on the actual graph, as well as describe it in words. So we are decreasing to the left of the vertex, and we are increasing to the right of the vertex. And that'll always be the way to describe it when we are U-shaped. That's not a technical word, by the way. I just call it that. Okay, now let's look at a rainbow. The vertex is here. The axis of symmetry is that vertical line. This is opposite, so we're increasing on this side and decreasing on this side. So go ahead, please tell me the vertex as a point. Tell me the axis of symmetry as a vertical line. Tell me the domain. Domain is always the same. And tell me the range. And this is rainbow shaped. Remember, we're going to have y is less than or equal to. And then behaviors. We are decreasing when, and we are increasing when. Fill that in, and this is a rainbow shaped parabola. Okay, so finish that off. And that is it for today. Tomorrow we will talk about graphing. Not tomorrow, today's Friday. Monday we'll talk about graphing. All right, I hope everybody's staying safe. Remember to post on our discussion if you have any questions. And send me emails for any personal concerns. All right? Okay, see you guys later.